You believe you know what an atom looks like. You've seen the drawings. A small nucleus sitting in the middle like a ball, electrons going around it like planets around the sun. Neat, simple, easy to sketch. That picture is in every textbook. Every science museum has a model hanging up, little balls on wires turning in perfect circles. But here is the issue. That picture is not right, not a little wrong, not almost correct. Completely, totally, fundamentally wrong, in a way that should make you doubt everything else you think you learned in school. The atom is not a tiny solar system. Electrons are not little planets. And if you try to understand what is truly happening inside an atom using that picture, you will not succeed. You will become confused. You will ask questions that have no answers because the questions themselves come from a false idea. So let me tell you what is truly inside an atom. And I am warning you now, you will not like it because what is actually there is so weird, so opposite to common sense, that your mind will resist me the whole way. Let's begin with the easiest atom, hydrogen. One proton, one electron. That's all. The atom everyone uses to explain things because it is supposed to be simple. You picture the proton sitting in the center, a little ball maybe 10 to the minus 15 meters across, and the electron is somewhere out there maybe 10 to the minus 10 meters away circling it. First question, where exactly is the electron? You might say it is over on the left side of the atom right now, moving in a circle. Incorrect. The electron is not over there. The electron does not have a definite position. Not because we can't measure it well, not because our tools aren't good enough, but because the electron itself does not have a definite place until you measure it. This is not philosophy. This is not interpretation. This is what the math says. This is what experiments prove again and again. The electron exists in a state we call a superposition. It is not here or there. It is here and there at the same time in many places at once. The electron is spread out in a cloud of probability around the nucleus. Now you might think, okay, fine, it's a cloud. So the electron is spread out like butter on toast, thinly spread over a region of space. No, that is still wrong. The electron is not spread out. The electron is a point particle when you measure it. But before you measure it, it does not have a position. What is spread out is the chance of finding it in different spots. There is a function called the wave function that tells you where you are likely to find the electron if you look. In some places, the wave function is large, high chance. In other places, it is small, low chance. In some places, it is zero. You will never ever find the electron there. But here's the thing that breaks your brain. Before you look, the electron is not hiding in one of those high probability spots. It is not secretly over there and you just don't know where. It really does not have a location. The wave function is the electron. That is all there is. Now let's talk about orbits because this is where the solar system picture really fails. You imagine the electron going around the nucleus in a nice circular path, round and round like a racetrack. Maybe it is going fast, maybe it is going slow, but it is definitely going somewhere. Wrong. Again, first problem. If an electron were really orbiting like that, it would be accelerating. Anything moving in a circle is accelerating, even if its speed is constant because its direction is changing. And accelerating charged particles give off energy. They send out light. That's basic electromagnetism. We can measure it. It happens. So if the electron were truly orbiting, it would be constantly losing energy, sending it away as light, and as it loses energy, the orbit would get smaller. The electron would spiral inward closer and closer to the nucleus faster and faster until crash, it hits the proton and the atom falls apart. How long would this take? Do the math. It takes about 10 to the minus 11 seconds, 100 trillionth of a second. Every atom in the universe should collapse instantly. Obviously, that does not happen. Atoms are stable. They do not collapse. So the electron cannot be orbiting. Okay, you say? So maybe it is not orbiting in a circle. Maybe it is just sitting there still, held in place by the electric pull to the nucleus. Also wrong, because if the electron was sitting still, we would know both its position and its momentum exactly. Position right there. Momentum zero. And quantum mechanics says you cannot know both of those things exactly at the same time. That is the Heisenberg uncertainty principle. It is not a limit of measurement. It is a basic property of nature. If you try to pin down the electron's position, its momentum becomes fuzzy. If you try to pin down its momentum, its position becomes fuzzy. You cannot have both. So the electron is not orbiting and it is not sitting still. What is it doing? It is not doing anything. It just is. It exists as a wave function, a mathematical description of probabilities. And that wave function has certain allowed shapes and energies. We call these shapes orbitals. An orbital is not a path. It is not a trajectory. It is a region of space where the electron is likely to be found, described by the wave function. The simplest orbital, the ground state of hydrogen, is perfectly round. The probability cloud is highest right at the nucleus and gets lower slowly as you move away. There is no orbit, no path, just a fuzzy cloud of might be here. Higher energy orbitals have stranger shapes. Some look like dumbbells, some look like donuts, some have multiple lobes. These are not physical objects, they are probability maps. Maps of where you might find the electron if you look. And here's the really strange part. The electron does not gradually change from one orbital to another. It does not slide smoothly from the ground state to an excited state, it jumps instantly. We call it a quantum leap. One moment the electron's wave function is in the shape of the lower orbital. The next moment it is in the shape of the higher orbital. There is no in-between, no smooth change. It does not travel through the space separating the two orbitals. It just jumps. How? We do not know. The math describes it, the experiments confirm it, but there is no mechanism, no explanation for how the electron gets from here to there without passing through the middle. It just does. Now, let's talk about what the electron actually is, because this is where things get really troubling. You think of the electron as a little ball, a tiny sphere with some mass and some charge. Maybe it is very small, but it is still a thing, an object, a particle. Except when we do experiments, we find that the electron also acts like a wave. It can interfere with itself. It can bend around obstacles. It can spread out and come back together. All the things waves do. So which is it? Particle or wave? Neither. The electron is not a particle. It is not a wave. It is a quantum object, something that does not have a classical comparison, something that shows particle-like behavior in some tests and wave-like behavior in others, but is basically neither. When you are not looking at it, it is described by a wave function. That wave function changes smoothly, spreading out, interfering with itself, doing all the things waves do. But when you measure the electron, when you actually detect it, you always find a localized particle, a dot on a screen, a click in a detector, never a spread out wave. The act of measurement collapses the wave function. The spread out probability cloud instantly becomes a definite outcome here, not there. One spot, localized. And nobody knows how this happens. Nobody knows what counts as a measurement. Nobody knows where the wave function goes when it collapses. This is called the measurement problem, and it has been troubling physicists for almost 100 years. There are interpretations, many worlds, pilot waves, objective collapse, but they are interpretations. The math works, the predictions match experiments, but we do not have a clear picture of what is truly happening. Let's make it worse. Let's add more electrons. Helium has 2 electrons, lithium has 3, carbon has 6, iron has 26. These electrons are all orbiting, no, wait, not orbiting. They are all existing at the same time as wave functions around the nucleus. But here's the thing. The electrons are identical, absolutely perfectly fundamentally identical. There is no way to tell them apart. Not because they look the same, not because they are very similar, because they are the same. Electron number 1 and electron number 2 are not two different things that happen to have the same properties. They are the same thing appearing in two places. This has consequences. If you swap 2 electrons, the wave function of the whole system changes sign. It picks up a negative factor. This is not a small detail, this is fundamental. It is called the exclusion principle, and it is the reason matter is solid, the reason you do not fall through the floor, the reason atoms have structure and chemistry works and life is possible. No 2 electrons can be in the same quantum state. If one electron is in a particular orbital with a particular spin, no other electron can be in that exact same state. They have to stack up, filling different orbitals, building the structure we call the periodic table. Without this rule, all electrons would fall into the lowest energy state. Every atom would be chemically identical. There would be no complexity, no molecules, no chemistry, no you. But why? Why does swapping identical particles change the sign of the wave function? We do not know. It is just the rule we found. The math works. The experiments agree, but there is no deeper explanation. Now let's talk about the nucleus, because you probably think that part is simple. A bunch of protons and neutrons packed together, little balls stuck to each other. Wrong. Again, protons and neutrons are not fundamental. They are made of quarks, 3 quarks each. Up quarks, down quarks held together by the strong nuclear force carried by particles called gluons. But the quarks do not sit still inside the proton. They are quantum fields changing, interacting, constantly exchanging gluons. The proton does not contain 3 quarks the way a bag contains marbles. The proton is a bound state of the quark field, a stable pattern of vibration. And here is the really strange part. Most of the mass of the proton does not come from the quarks themselves. Quarks are almost massless. Most of the mass comes from the energy of the gluon field holding the quarks together. Energy equals mass. So when you ask what is inside a proton, the answer is energy. Bound field energy, not stuff, not particles. Energy arranged in a stable pattern. And the protons and neutrons in the nucleus, they are held together by the leftover strong force. They are not touching, they are not glued together, they are trapped in a potential well made by the exchange of particles called pions. But pions are also made of quarks. It's quantum fields all the way down. So let's step back and ask the question again. What is truly inside an atom? Not particles, not little balls, not orbits, not stuff. What is inside an atom is fields. Quantum fields, the electron field, the quark field, the gluon field, the electromagnetic field. These fields fill all of space. They are everywhere, always. When we say there is an electron in an atom, we mean the electron field has an excitation near the nucleus. The atom is not a thing. It is a pattern, a stable arrangement of field excitations held together by forces that are themselves carried by other field excitations. There are no solid objects at the bottom. There is no stuff. There are only fields. And the fields are just mathematical objects that give numbers to every point in space and time, numbers that change according to differential equations, numbers that sometimes make localized excitations we call particles. You don't like this. I can see it. You want there to be something real at the bottom, something solid, something you can point to and say, that is what it is made of, but there isn't. There is just math, equations, symmetries, conservation laws, and somehow miraculously that math produces the appearance of solid objects, tables, chairs, your body. All of it is patterns in quantum fields held together by forces, stabilized by exclusion principles, flickering in and out of existence trillions of times per second. Here's another thing that is going to bother you. The atom is mostly empty space. You've probably heard this before, but that is wrong too, because empty space does not mean nothing. The quantum fields are still there. Virtual particles are popping in and out of existence. The vacuum is full of activity, and the electron's wave function fills the whole atomic volume. The electron is there in the sense that its probability amplitude is not zero throughout the atom. When you push on a table, you are not feeling particles colliding. You are feeling the electromagnetic push between electron clouds, field setups resisting overlap, the exclusion principle preventing electrons from being in the same state. It feels solid because the forces are strong, but there is no actual contact, no touching, just fields pushing against fields. Let's talk about size, because this is where your intuition completely fails. The nucleus is 100,000 times smaller than the atom. If you scaled the nucleus up to the size of a marble, the atom would be the size of a football stadium. But here's the thing. The electron itself, as far as we can tell, has no size. It is a point particle. Every experiment has come back with a result consistent with zero. So you have a point particle with no size somehow taking up a volume 10 to the minus 10 meters across. Does that make sense? No, of course not. But that is what the experiments tell us. Nature does not care whether it makes sense to you. Now let's make it even worse. Let's talk about spin. Electrons have a property called spin. It acts like angular momentum, like the electron is rotating, but the electron is not spinning. It cannot be spinning because it is a point particle. A point has no size, so it cannot rotate. There is nothing there to spin, and yet the electron has angular momentum, built-in angular momentum that does not come from motion. It is just a property the electron has like charge or mass. We call it spin because it has the mathematical properties of angular momentum, but it is not actual rotation. This spin is quantized, spin 1/2. You can measure it along any axis, and you will always get one of two answers, up or down, never anything in between. But before you measure it, the spin does not have a definite direction. It is in a superposition, and the moment you measure it along one axis, it becomes uncertain along perpendicular axes. Why? We do not know. It is just how spin works. Nothing in your everyday experience acts this way. Energy levels in an atom are quantized. The electron can only have certain specific energies, not any old energy, specific separate values. Why? Because the wave function has to fit around the nucleus. It is like a vibrating string. A string can only vibrate at certain frequencies, the fundamental and the harmonics. Same with the electron's wave function. Only certain wavelengths are allowed. And since energy is related to wavelength, only certain energies are allowed. When the electron jumps from one state to another, it sends out or takes in a photon with exactly the energy difference between the two levels. This is why atoms give off light at specific wavelengths, why hydrogen has its characteristic red line, its blue line. Each line matches a specific jump between energy levels. We can measure these wavelengths very precisely. We can predict them using quantum mechanics very precisely. They match to 10, 12, 14 decimal places. The theory works. But why are energy levels quantized? The math tells us. The experiments confirm it, but there is no deeper reason. Now, let's talk about what happens when you try to look inside the atom. You cannot use visible light because the wavelength of visible light is bigger than the atom. You need something with a shorter wavelength, higher energy. But here is the problem. The moment you use high-energy probes to look at the electron, you disturb it. You knock it out of its state. You change what you are trying to measure. This is not a technical limit. It is fundamental. To see something small, you need short wavelength light. Short wavelength means high energy. High energy means large disturbance. You cannot avoid it. The act of measurement changes the system. There is no such thing as a passive observation at the quantum level. This is why we cannot say where the electron is before we measure it. Not because it is hiding, but because the property of being in a definite location does not exist until we perform a measurement that creates that property. Before measurement, the electron is described by a wave function, a superposition of possibilities. After measurement, the electron is in a definite state, one of those possibilities. The measurement does not show a pre-existing reality. It creates a definite reality from a fuzzy one. So what is truly inside an atom? Not little balls, not orbits, not stuff, not even particles in the way you think of particles. What is inside an atom is a mathematical structure, a wave function, a solution to the Schrödinger equation, a pattern of probability amplitudes that tells you what you will find if you look, but does not describe a definite reality when you are not looking. The atom is a quantum system, and quantum systems do not behave like anything in your everyday experience. They exist in superpositions. They have properties that are fundamentally uncertain. They defy imagination. You cannot picture what is inside an atom because there is nothing to picture. The wave function is not a physical wave in space. It is a function in an abstract mathematical space called Hilbert space. It is a list of complex numbers that store probabilities. It is information, not substance. And yet, from this abstract mathematical structure, the entire physical world comes out. Chemistry, biology, consciousness, all of it built from patterns in quantum fields governed by equations following rules that make no intuitive sense but work with amazing precision. This is what is truly inside an atom. Not particles, not stuff, but math. Pure, abstract, beautiful, incomprehensible math. And if that does not satisfy you, if you still want there to be something more, something solid and real at the bottom of it all, well, I am sorry, but the universe does not care what you want. It is what it is. And what it is far stranger than you ever imagined.